This is the testing video for my A-level Computer Science NEA. My name is Raj Shreyas Raveen Kumar, candidate number 3072, center number 16437. And this will be the testing video for my project, and the project name is FundSim. I'm going to start with test 1C III, part 1, part 2, and part 3, where I will test the successful registration and error handling of the registration process. So I will run the program now. So the program obviously has created the UI here, and I can now enter a username and password. So 1CII test the registration. So user 1234, and I can enter a password, password 1. Now, if I register this, it has successfully registered and immediately entered into the portfolio list view screen. So this indicates a successful registration. Now, if we go to the database and verify this, go to users table. Now, test user, we just registered this with the password, and is updated the database with the user as well. So that suggests that 1CII1 is passed. Now, let's log out and create a entry, which is a boundary entry. So minimum 3 characters for the username and minimum 8 characters for the password. So 1, 2, 3, 4, 5, and 6. So that's 8 characters. 1, 2, 3, 4, 6, 7, 8. So now if we say register, it should successfully register. And once again, if we go to the database, let's open the database again and go to users. As you can see, it has updated with the new user. So that suggests 1C is passed. Now to test 1D, the logout button, so we are already logged in, and the user name is XYZ. So if we press logout, it should clear the session details and redirect back to login screen. And it does that. And that suggests that 1DI and II is passed. Now I'm going to test objective 2, which is portfolio list and portfolio creation. So if I log into a test user account, okay, so there are already a couple of created portfolios here before, but if we say, so the portfolio list, of course, it should display portfolio name, ID, and the creation date, which it does clearly here. And if we look at the database corresponding to this, look at the portfolios, and we look at well, the user ID of test user is 1. And if we go to the portfolios table of the user ID 1, we can see that this is the creation date, 2025, December 12th, 18th of December. And these portfolio names and the cash values correspond to these ones as well, as you can see. So that suggests that AI and AI and the subparts of AII are successfully passed. Now, if we, for AIII, the list should update after creating a new portfolio or returning from another screen. So if we create a new portfolio, and we can call this test portfolio, okay, and we inject an initial cash amount of, say, 10,000. Okay, so it goes directly to the portfolio holding screen. And then if we go back to the portfolios list screen as shown here, it updates with the new portfolio and the new portfolio ID um, from the database. And it shows all the required details here. Now, if we verify with the database, we can see that we should close this and reopen it. And we look at portfolios. Now, if we look at all of the portfolios with the user ID 1, we can see that here it's a new portfolio has been created with the initial cash amount of 10,000. And today is the 2nd of the 9th of February, 2026. So this is successfully done. So 2II is also passed. Now, for 2B, 2BI, 2BII, and 2BIII, we are told to test the create portfolio button, which I just did. So 2I and 2II are passed. For 2III, which is the validation rules, the portfolio name should not be empty. So if we try to make the portfolio name empty, it doesn't create a portfolio, as you can see. And if the initial cash must be numeric. So if we say, for example, XYZ and initial cash amount is, it's not a floating point value, try again. So that's what it does. And the error handling is smooth. And initial cash should not be negative. So if we type in negative value, the minimum allowed value is 0. So it clearly handles that properly. Now, after creation, the user should be immediately directed to the newly created portfolio view screen. When we created the test portfolio, we were immediately redirected. So therefore, 2BIV is passed. Now, if we test for 2C, the open portfolio, the user should be able to select a portfolio and open it, either via clicking it twice or selecting an open portfolio button. So if we look at this and click it twice, it's open. And if we try the other functionality where we open the selected, and to check this, to check the integrity of this, if we just not select anything and press this button, it shows a error message saying double click portfolio row, as you can see. So 2C is passed. Now, 2D is a persistence requirement test. So if we log out and we log back in with the password, you can see that the user portfolios are persistent between the sessions. Now, we just logged back out and logged back in. So 2DII is clearly satisfied. Now moving on to objective 3, which is portfolio view, holdings, display, and core state. Now, if we go to a particular portfolio, for example, this portfolio here, and we only have one holding here, and it should display the current cash, current holdings value, and the total portfolio value, which, as you can see, it does display this. So 3AI, 1, 2, and 3 is passed. Now 3AII, where the value should update after any transaction of buy, sell, deposit, withdraw, undo, and redo. If we test that by buying Amazon, for example, the ticker is AMZN. Quantity is, for example, 1. So we just bought one Amazon stock. And that is at the last price of 208.72. So the buy, after the buy operation, it has updated. Now, if we sell the stock we just buyed, entity 1, now that also has clearly updated, and the holding value, the cash, all of that has also updated correctly. Now, if we withdraw a certain amount of cash, now, for example, we can withdraw 459 0.88, just to make it clean, clean number. Uh, okay, that has gone to 9,000. So clearly that math works correctly. Now, if we deposit, for example, 1,000, it should go to 10,000. And yes, that works correctly. Now, if we undo a particular transaction, for example, the latest one was we injected 1,000, undo, it goes back to 9,000. Cash goes back to 9,000, as you saw. And if we redo this, it goes back to 10,000. And if we press it again, where there is nothing to redo after the latest action, it shows the message correctly. So therefore, 3A is passed. Now, the holdings table, um, which is 3B, is passed because the table includes the ticker symbol, quantity held, average buy, current price, and current market value, and profit and loss as well, where we bought this in, when was this? This was in but the date of the creation. So this was bought ages ago, in 2025, when I did create this portfolio and bought it for testing purposes. So as you can see, the transaction ID there is 4, and the date is 2025 12/18, and the time is also written. Sorry, the time is also recorded. So for 3BIV, there should be a button allowing the user to refresh prices of holding. So if we refresh the prices, it does actually call the API and get the latest price, but obviously it doesn't change very often, and there is a delay with the Y Finance API, hence the profit and loss and the latest price isn't changing currently. Now, testing for uh, 3IV, um, sorry, 3IV7. So when the portfolio is initially opened, prices will automatically be refreshed. So if we go back to portfolios and we just open this one here. Now, if we open this one here as another one, um, clearly this is the latest price because we just saw this price in the previous one, and the profit and loss is also the same because uh, that is what the previous one showed. Let me just confirm that again. For example, there you go. Now this was bought at a slightly different time, slightly earlier or later um, than the previous portfolio. Hence, there is a slight difference of profit and loss of $9.32 instead of $9.36. $9.14. What was it again? One second. $9.12. Yeah. Now, navigation controls, there should be a back to portfolios that works. There should be an access to analytics and backtesting features from the screen. So if we look here, there is an analytics button here, and the analytics screen uh, shows successfully, and there is a backtesting option here as well, where the correct input prompt is given. Therefore, these buttons are existent and they do function. Furthermore, there is a logout functionality as well, which is 3CIII. And if we press this, we are taken back to the login page, login screen, which works. And therefore, all of Objective 3 is passed. Now, if we look at Objective 4, which is transactions, buy, sell, deposit, withdraw, the general transaction requirements are the user should be able to initiate transactions. So let me just log in again real quick with a previous account that I created for testing purposes. So now if we create a portfolio, for example, test PF, okay, initial cash amount again, give it 10,000. Okay, so the ID is 11. So the user should be able to initiate transactions via clearly labeled controls. So these controls are here. So we can buy Apple as shown. Okay, and we can sell um, the ticker as well. So clearly the amounts update, and the deposit and withdraw functionalities were also tested previously, and hence this part of section 4.4a is passed. Now 4b is also passed. 4bi is also passed because we just were prompted to enter the ticker symbol and the quantity to buy. 4bii, the ticker validation, if we try to enter an erroneous value, so for example, we try to enter this, and we are continued to the quantity, but if we then press OK, we are given the invalid error message, invalid ticker, which works perfectly well. Then if we, for example, enter a valid ticker, and then we enter an erroneous quantity, it has to be at least 0.001 because fractional shares are allowed in the simulator as outlined in the documentation. So if we say, for example, quantity is a character, then it's not a floating point value. Now, if we enter a correct floating point value, then it updates with the correct details. Okay. The ticker validation therefore works perfectly. The quantity validation also therefore works perfectly. Um, the cash, now, if we try to buy a higher amount of shares than we can afford, uh, than how much cash there is to buy them, now it should show an error message, um, show a warning. So if we enter a ridiculous quantity, it says we don't have enough cash. We need this amount, but we only have this amount, which corresponds to the cash amount shown here. Now, therefore, the cash validation works well. And if we, for example, after a successful buy, the cash decreases correctly. We tested that in the previous test where I logged in as a test user. Holding quantity increases correctly. We also tested that just now. Average purchase price updates correctly when buying more of an existing holding. Now, for example, if we buy a new share of Amazon, then now we buy a quantity of, say, 10. Okay, now the average purchase price is 208.72. Now if we buy five more of this, it will not update because it doesn't update in a short time frame, like minutes. So if we go back to an existing portfolio, um, for example, this portfolio here, and we look at the last price is 417, and the average purchase price is 481. So if we buy, say, 8 more of this, the average buy should decrease by a correct amount. Now, for example, 417. So, oh, sorry, this is the ticker. So TSLA. Quantity is 12. So quantity we were going to buy, sorry, is 8. Okay. Now the average purchase price has the average buy is what's shown here. Is decreased to 455 since the last price was 417. So that should reduce the average, and that is successfully done. And the quantity is also updated successfully, as is the cash. So therefore, this functionality works. And 4B is therefore passed. Um, yes, now testing for functionality number 5, undo and redo functionality. Now this is the undo redo buttons over here, and this is the transaction history which we can view, um, which shows which undos have been done before, and any undos and redos will update the transaction history. So this is the top is the latest is the latest one. No, sorry, the bottom is the latest transaction. Uh, yeah, so it's shown in ascending order. Now, if we try undo the latest one we did, so it should go back to 12. So as we saw, the undo works correctly. Um, and if we keep undoing it until we reach uh, zero value, the initial portfolio state when we created it, uh, then it shows nothing to undo. So if we keep pressing it, there is this message box which handles the error gracefully. Now, if we redo all of the actions, it goes back to the portfolio state we are in. And bear in mind, some of these transactions were done in uh, multiple days ago. So the transaction history clearly it clearly persists and correctly rebuilds the portfolio based on the undo and redo uh, buttons, and any erroneous presses of the button are handled gracefully. And as you can see, it has updated with the undos and redos that we have done. So therefore, 5A and 5B are passed. And 5C, which is the persistence reopening behavior. So if I close this portfolio, back to portfolios, and reopen this portfolio again, um, and this is a new session, obviously. So if I even try to redo this, um, so clearly those actions are currently being redone as well, and sorry, undone as well. And if we redo these actions, those actions are redone. So the persistence is on point, and therefore 5C is passed. But for a confirmation check of 5C, if we log out and log back into the user that I was operating under. Now, if we go back to the portfolio we were testing, now if we try to undo the latest transaction, there we go, it shows 12. Now, if we try to redo this transaction, it shows 20. So the between sessions, the undo and redo persists. For a final check, if we just close the program and quit the app as shown, and we rerun the app, give it a second to load. Yep, there we go. Now, if we enter the credentials, go back in and go to number, sorry, my bad. It could be this. Yep, there we go. Now, again, if we undo, it goes to 12. If we redo, it goes to 20. So even between closing and opening of the program, the undo redo functionality persists. So therefore, objective number 5 is achieved. Now, objective number 6, single portfolio analytics, performance and risk metrics is what we are going to be tackling in this one. So analytics access is given in the portfolio screen. So this is a clearly identifiable method. So therefore, 6A is passed. Now, if we look at um, the equity curve shows the portfolio value over time. And this one is a slight anomaly because it hasn't the holdings haven't changed for a long time, and the holdings are um, quite insignificant compared to the cash value. So it's unlikely that the equity curve is going to have a lot of visible fluctuations. Although we do have one here where we withdrew 50,000 from here and then injected it back just to test whether it would work. And for the verification of that transaction, we can see that here where we deposited 50 grand and we undid that deposit again, and then we've deposited it again. And that's what the massive dip, sorry, in the equity is showing. Uh, so the equity curve is the cash and the value of the holding. So if we see it's around 60,000, so and we end at 59,088. Now, if we go back and add the cash value and the holdings value, we do get 59,088.92. and this total value is extrapolated to the equity curve. So therefore, 6B is passed, and it does reflect the effects of buy, sell, deposit, and withdraw actions, because the one where we uh, bought the, sorry, let me show you another portfolio where this is better shown. For example, this portfolio here. Now, if we go to the analytics, uh, again, it's quite a big jump, but we can see more fluctuations due to the trades we have made. Um, and for example, in February, literally a few days ago, there's a massive jump in value, and that will correspond to an injection in cash. So if we recently deposited 10,000 on the 4th of February, and that corresponds to a massive jump in the value of the equity, um, as you can see here, and the uh, effects of the buy sell actions are also shown in the fluctuations of the graph, the tiny fluctuations of the graph you can see here. Now, if we look at the metrics display, again, go to analytics, and the metrics are shown correctly. The metrics are at least are computed correctly and shown in the correct format. And all the specified metrics are shown, the specified metrics in the objective outline. Um, and for example, if we look at now the rolling volatility is a 30-day metric, so we need to have at least 30 days of data to calculate the rolling volatility, to have, of course, as outlined in the documentation, an accurate volatility or a meaningful volatility. And if we go to a portfolio that was created recently, as you can see, there is a portfolio created today for testing purposes, which we created. Now, if we double click open and it loads and analytics, if we see here, we only have one data point because it was created today. So these metrics cannot be calculated unless there are at least two data points, specifically the um, return, the Sharpe, the max drawdown, as well as the CAGR. Rolling volatility, of course, needs 30 days value. Now, if we look at a portfolio that we created a few days back here, and we go to the analytics, um, again, the portfolio value has stayed the same since there are no holdings and there were no there was, if you look at the transaction history, there was no transactions, so this portfolio has just been stagnant. So it's this portfolio here. Now, if you go to the analytics, it doesn't show anything. The total return, the CAGR, and the max drawdown are computed as 0%, but the rolling volatility requires 30 days of value, and the Sharpe ratio also requires fluctuation in order to compute. So um, the rolling volatility is therefore shown correctly, as well as is the other metrics. Now, to, we've done two tests. Now, if we finally do another test here, the an example portfolio with Google and a company called Rumble Holdings. Now, if we go to analytics, rolling volatility, everything else is computed properly because there are multiple data points and fluctuations, but rolling volatility is not computed because it was only created, 8 days ago, a week ago. So it needs at least a month's data to calculate the rolling volatility. So that works perfectly fine. Now, therefore, uh, objective number 6 is achieved. Now, objective number 7, if we look at the backtesting, the backtest is launchable from within the program, and the backtest will run on the portfolio's assets. So 7A is achieved. Now, the backtest configuration is the rebalance frequency of a month, which is the industry standard. And we should be able to specify the start date and the end date. The format is given here. Um, and if we try entering an erroneous value, invalid string error is shown as a message, and the program doesn't crash. Now, if we enter another erroneous value, if we just enter strings instead of numbers, again, it's shown this here. Now, if we enter a date, but it's an invalid date, for example, we enter the start date of a future start date. For example, if we do 2300 so month day, um, and we do the end date as a previous date, for example, 2000 end date must be after the start date. Now, if we enter the start date correctly, but the end date wrong, let's see how that works out. So the start date, for example, let's put it at 2015 0101. Now, the end date, if we put it at 2000 let's see. The end date must be after the start date, so it does compute these values correctly and shows an error message correctly. So now let's run a valid backtest with 2026 0101 to the latest date today, so that is 2026 0209. And as we can see, we do see an equal weight backtest computation. However, um, the rolling volatility isn't calculated, but all the other metrics are clearly calculated. So while the rolling volatility does behave unexpectedly, all the other metrics are computed, the program doesn't crash, and the portfolio value over time with this equal weight strategy is shown. Now, if we do a longer backtest, for example, we start from 2010, and we go to the start of 2026. There we go. We see a more more fluctuated equity graph of the backtest because it's over a longer time period, and we can confirm that the program can handle large data sets. Obviously, all the historical data of these years in the backtest is taken into consideration. And the rolling volatility is calculated here, um, although the previous one should have at least a 30-day value calculated. But the reason it didn't have a 30-day value calculated, it's actually, sorry, no, it wasn't unexpected. It's because there wasn't enough trading days. So in the weekends and in the holidays, in the bank holidays, the market is closed, and therefore technically, there are no values for that day. So hence, uh, this amount. So this is just over a month, but there are 4 weeks at least in the gap between this backtest. So that is 8 days. So that is at least 4 weekends. So if we take away 8 days from this value, it does come down to less than 30 days, less than a month's data, just about. Hence, the rolling volatility isn't calculated. But if we, for example, say 2025 12 01, and then we go to 2026 0201, so that's around 2 months, it should calculate C, so it does calculate when we enter a slightly longer time period. So the rolling volatility does actually function. So the backtesting algorithm works as expected. And it doesn't modify the portfolio state either, as we can see, because the backtest tests it's a closed simulation, meaning it doesn't actually affect the rest of the program. It's for informational purposes, and it uses a start equity value of 10,000, regardless of whatever the portfolio cash is. So, as you can see, the holdings are not affected, the cash is not affected, they're the same. So, hence, objective number 7 is achieved. Now, objective number 8, we are testing the export functionality. Now, for a more reliable test, we are going to go back to the portfolios and enter and try to do it for a larger portfolio of holdings. Wait, let me see which one has the most holdings. All right, this one has 1, 2, 3, 4, 5, 6, 7, 8 holdings, 8 stock company holdings. Um, as you can see, and we are going to attempt to export this in both a CSV format and an Excel format. So if we try exporting in Excel, we are given this prompt here. And if we go to, for example, the iCloud here, and we try to save it, and we can customize the name obviously as the name entry is given here. The entry prompt is given here. Sorry, the entry field, that's what I should say. So it gives us a saved notification to the path, the corresponding path. Now, if we go to the, where do we go? iCloud, here it is. If we go here, this is the exported Excel sheet. And if we open it, we are shown the start date and the end date of the portfolio values. And if we test that against the actual portfolio values for, okay, and for example, if we go here, the start date is the start is 2025 12/18 to 2026 02/09. Now 2025 12/18, 2022 02/09, and the start equity is 10,034 as shown, and the end equity is 19,654 and it's shown. So if you map the rest of the metrics to the document that does correspond. The holdings, Apple, Amazon, there is 1, 2, 3, 4, 5, 6, 7, 8. And there were 8 holdings of these exact values in the portfolio screen view. So that also checks out. Now, if we go to the transactions, this is the transaction history that is also exported with the Excel file. If we open the transaction history, this transaction history is also shown here. Now, for example, just as a quick sanity check, if we look at 103, which is the latest one, that was a buy of Tesla of 13 shares at 406, and the status is not reverted, so in other words, it's active, and the value of that is 5278. Now, if we go here, again, quantity is 13, price quantity is 13, and the is reverted is 0, meaning that it hasn't been reverted, so the holding is still there. And this field is obviously empty as shown here. So the transactions is exported correctly. Now the equity curve shows, if you click on the date, it shows the date. So it does function properly. We just have to click on it a couple times. And it shows the values of every single day until today. So how the portfolio value has changed. So it just shows the cash, the holdings value, and the equity. So if we look at the start equities, 10,034 on the creation date. Now, if we just go to the analytics, 10,034 is about there. And if we look at here, the portfolio value, it should be, the equity value should be, 19,654, which is around here, which does check out. And these values show the holdings value and the cash components and how they've changed. So any injections, any withdrawals can also be tracked. And if we, for example, look at the latest one of the what was this, holdings value is 14,000 and the cash is 4,900. Go back. Now the holdings value is 14,743, and the cash value is 4911.53, which does check out. So the Excel sheet export functionality does work perfectly well, and therefore, um, save that, and therefore the objective 8 A and B number I2 is achieved. Now we are going to test the same thing, but for the CSV format. So if we export the CSV file here and we go to the iCloud, and then we save it as this, so we can obviously change the name to whatever we want. We could just remove these trailing numbers, which are the dates and the time. Save. So it creates 4 separate CSV files with the analytics, the equity, the holdings, um, and the transaction history. So these are 4 separate CSV files that are created, and it notifies us of this, that it's created in this path, and these were the files that were created. Now, if we open this path, which uses Raj Kumar library, that Cloud Docs, which is the iCloud, here you go, there we go, iCloud, and we can see here that it is saved as a folder. Now, if we open the folder, there are 4 files, and these are the corresponding equity, the holdings, and the metrics and the transaction files. So if we open each one and check, this does open as a in the Numbers app by default. So I can just change that to open with text edit. So this is the CSV file. The comma separated values are here. And as we saw earlier, the latest transaction was a buy of Tesla of 13, 13 quantity 13, and the average price was this value here. So the transaction is exported correctly. And if we look at the metrics, again, this is just opening in the Numbers app as a default, but we can open with text edit as as I just showed. But this is more convenient for us to analyze. So these star equity and the metrics here do correspond with the metrics shown in the screen. So this also passes. And the holdings of 1, 2, 3, 4, 5, 6, 7, 8 are the same holdings here. So that also passes. And portfolio 3, the equity curve, these are the equity values, and these are the corresponding values as well. So this also passes. Therefore, the exporting data functionality is passed. Now, the penultimate functionality of Objective 9 is the cross-portfolio comparison and advanced risk analytics. So if you go back to the portfolio screen, we can perform an advanced risk analysis, which uses matrix operations, and this is called PCA analysis. And if we select multiple portfolios and compare the selected, we can run the analysis here of the cross-portfolio analysis. But for just as a validation check, if we just don't select anything and just select one, it does show the error message without crashing the program. Now, if we go to the compare selected, and we had the original 3 that I selected. Now, if we run analysis, it should generate a heat map and a bar chart showing the PCA factors. Now, there is a table underneath here as well, and this table and the correlation matrix are generated successfully, as well as the metrics, how many observations there are, and the main factor that's driving the trends of whether it's increasing or not, with the value, sorry, is increasing or not, the equity value. And the correlations are shown. The correlation matrix is shown as a heat map here, which ranges from -1 to 1. So there aren't any values below -1. There aren't any values above 1 either. So that one does pass. And the table below shows each portfolio's contribution to the PCA explained variance. And as we can see, the main one here, which is nearly 100%, is these 3 values here. And we can see that, for example, the tech portfolio has a PC value of 0.9977, which shows that this portfolio here is the major cause of the way all of these portfolios combined will move. So that's what it shows. And the bar chart and the correlation matrix does correspond to these values. The only thing is this is as a percentage and this is as a decimal value, but that is fine because that is the industry standard. So now the comparison window, or all of that was also shown correctly if we see the creation date of these three portfolios. Um, the latest one was 0131 and the date today is 0209, and by default the analysis runs the maximum range of values to get the most accurate figures. And there were only 9 observations, which corresponds to the 9 days. They were 9 trading days there were during 9 trading days there were from the creation date of portfolio ID 7 and today. So that passes. Um, and hence 9A, B, C, and D pass. Now, if we try to test for the responsiveness and concurrency, now we compare these three again, and we run the analysis multiple times. The latest one is shown. And if, for example, if we go back to compare selected again, oh, sorry, let's sample these. The screen is obviously erased. And if we try running a different analysis, so we're running this back to back, so we're running this quite frequently. Compare selected, run analysis. So okay, this one can't run because there are a couple portfolios created today, and for at least a minimum acceptable outcome, there has to be at least 3 days of overlapping periods between the portfolios. Um, and if we, for example, do that here, compare selected, run analysis. There we go. It's a different one that's shown. The values are also different. And we run it again and it doesn't fail. So the API responses and the analysis calculations run correctly. Uh, and if we look at the final objective, the reliability, the data integrity, and the general validation, we've seen that the program doesn't crash, and the data does persist as these creation dates do map to the creation dates of the portfolios. As you can see, um, the portfolios created here do map to the portfolio dates created here. And the users also persist. As we can see, I'm currently under the user Raj, and there are all of these users here, and this is the user that I'm currently under. So the data persistence is passed. And graceful error handling is what we have seen throughout the entire program, as the program doesn't crash and shows us the error message where relevant. Hence, objectives are achieved, and that concludes the testing for FundSim and hence my NEA. This testing section is to cover tests that were originally omitted in the previous one. So let's get straight in. We'll start with test 2DI, which tests for persistence requirement when programs are closed. The user portfolios should still persist. So so obviously the portfolio simulator is already open. Let's try closing it and opening it back. So this is the database with all of the users. If we go to the users table, now these are all the users that are stored. Now, if we run the program again, and we try logging in, these were one of the users. And as we can see, the portfolios persist across sessions. So 2DI is passed. Now, moving on to the next one, which is 4C. And 4C tests for selling shares. Now, selling shares, if we go to one of the portfolios, for example, this portfolio here, the user should be able to enter the ticker symbol and the quantity to sell. So if we press the sell button, we are given the ticker prompt. For example, let's sell TSLA, and quantity can be, for example, 10. And as you can see, that works. And therefore, C4CI is passed. and 4CIII is passed. Now we want to test 4CII, which is validation. And if we, as we just ran a normal data test, let's try running a erroneous test where we try to sell a ticker that we do not own. So for example, AAPL is not owned, as you can see in the ticker list. So if we try selling this, it says no holdings for AAPL. So a correct error message is given. Now, if we try to sell a existing ticker, but we enter, for example, a uh, zero number, the allowed minimum value is 0.0001 as fractional shares allowed. So that boundary data is handled correctly. And if we try another erroneous data, for example, -12, again, the minimum value is 0.001. Now, if we try entering a random string of characters, again, not a floating point value. So erroneous data is completely handled correctly. Now, um, 4D, so therefore 4C is completely passed. So 4D is tests for cash deposit. So if I try depositing cash, the um, amount must be updated correctly. So let's try depositing, for example, $1,000. So $1,000 means that it should be 52,266.54 after I deposit this amount. So as you can see, updated correctly. Um, and if we try doing erroneous and boundary data, where is it? Deposit amount 0, minimum value is 0.01. So as you can see, the boundary data is handled correctly. And if we try putting 0.01, it does update. It was 5.4 before, it became 5.5. Now, if we try depositing uh, a negative number, again, allowed minimum value is 0.01 shown, so error message is shown correctly. And um, if we try inputting a random string, again, not a floating point value, it handles the errors correctly. So again, all error handling is done correctly, therefore 4D is passed. Now 4E, which is cash withdrawal, we do the same test but for withdrawal purposes. So if we enter an amount, for example, we try doing 266.55. I chose this number so that it would become a clean 52,000 after this happens. So let's try doing that. Again, as you can see, 52,000. The calculation was handled correctly, the withdrawal calculation. Um, and hence 4EI is passed and 4EIII is passed. Um, and as we can see, a transaction has been created for both the deposit transactions that we've done of 1,000 and 0.01 and the withdrawal transaction that we've done for this latest test. And the transaction ID for the deposit was 141. Transaction ID for the withdrawal was 143. Um, so if we try doing erroneous and boundary data for withdrawal, um, now let's try doing, for example, 0. Again, 0.01. Now, if we try inputting 0.01, which is the minimum value, it does decrease to 51999.99. It was 52000 previously. Now, if we try withdrawing a negative number, we are given the minimum allowed value is 0.01. So error handling is done correctly. Now, if we try inputting as the same a series of strings, sorry, a series of characters, I should have said, not a floating point value, please try again. Error message shown correctly. So therefore, 4EII is also passed. Now, moving on to the next test that we omitted originally, which was 5BIV, which tests for uh, the branching rule. Now, the the redo button redoes the latest redoes the latest undone transaction, or the latest undone transaction. So if we try redoing something now, it doesn't work because uh, we've already done a transaction after that breaks the undo chain. So now if we undo the previous transaction and we redo it, it does redo. But if we then, for example, buy Apple shares, for example, we buy uh, 10 Apple shares and we try redoing it, there is nothing to redo because the latest transaction has uh, disrupted the redo stack and thus correctly emptied it. Hence the branching rule, where if the user performs a new transaction after undoing, the redo history is cleared, is passed. Hence, the objective 5BIV is passed. Now, the next test, which is 7BIII 6 and 7, which is the 7BIII 6 and 7, which is there must be at least one valid asset to backtest. Now, if we go back to portfolios and look at this portfolio here, which we created early in the testing, um, there is no valid asset to backtest, hence the backtesting shouldn't actually uh, run. Now, if we try running equal weight backtest, portfolio must contain at least one asset. So the error message is correctly shown. Hence, 7BIII 6 is passed. Now, for 7BIII 7, if we try doing, for example, we buy 10 Apple shares, sorry, 10 Apple shares would be too much. If we buy one Apple share, oh, my bad, I entered the wrong one. PL, there we go. Now, if we try backtesting this for a ridiculous time period where Apple did not exist, analytics, run equal weight backtest, we try no price data return for the backtest period. So, um, therefore, number 7 of 7BIII is passed. Now, for the final test that we omitted, which was 8D, 8D tests for uh, export robustness. So if we cancel the dialog, if we cancel the export, then the export should fail gracefully, and the program shouldn't crash. So, for example, we try exporting the Excel file for this portfolio, and then we cancel it. It cancels perfectly fine. If we try doing the same with the export CSV, um, and try exporting that, cancel, it should be fine. And therefore, 8D is also passed. This concludes the additional testing section.